Good morning, everyone. I am Charmin Divina Tinambakan, a reporter from Group 5, and we will tackle about geology and non-renewable minerals. So, geology refers to the study of Earth's structure and a history of the rocks. So, my report is under the rock and minerals. So here are the pictures of rocks and minerals. They are just the same in structure, but the minerals have a crystallized shape. So this is the rocks. So by the way, the rocks is a combination of one or more than mineral formations, while the mineral is a solid formation that is having a crystallized shape. So rocks are generally made up of two more minerals. It is mixed up through geological processes. For example, granite is an igneous rock mostly made from different proportions of the minerals quartz, feldspar, and mica as interlock crystals. As a sandstone is a sedimentary rock that can also contain quartz, feldspar, and mica, but as grains compacted and cemented into each other. So these are the different types of rocks. We have the igneous, the sedimentary, and metamorphic rocks. So we will just go back later. Igneous rock. So igneous rock or magmatic rock is one of the three main rock types, the others being sedimentary and metamorphic. Igneous rock is formed through the cooling and solidification of magma or lava. The magma can be derived from partial melts of existing rocks in either a planet's mantle or crust. For example, this igneous rock is formed through a volcanic eruption. The next type of rock is the sedimentary rock. Sedimentary rocks are types of rock that are formed by the accumulation of deposition of mineral or organic particles at Earth's surface, followed by cementation. And sedimentation is the collective name for processes that cause these particles to settle in place. The third type of rock is the metamorphic rock. A metamorphic rocks arise from the transformation of existing rock to new types of rock in a process called metamorphism. The original rock is subjected to temperatures greater than 150 to 200 degrees Celsius and often elevated pressure of 100 megapascals or more, causing profound physical or chemical changes. So let's go back to the types of rocks. So under the igneous rock is the granite, the scoria, the pumice, and obsidian. Under sedimentary rock are sandstone, limestone, shale, conglomerate, and gemstone. So sedimentary rocks are those rocks under a crystallized, or that's why there are sandstone. And also the sand is an example of mineral because it is from a crystallized mineral from Earth's surfaces. So metamorphic rocks are marble, slate, quartz, and gneiss. So we are going to tackle about the minerals. This is the picture of minerals. So it is beautiful to look at because of its wonderful colors, textures, and its different shapes, and also it is look like a crystals. So minerals Minerals are naturally occurring elements or compounds that have been formed through slow inorganic processes. Extraction of minerals is carried out through mining. Minerals are extracted from beneath the surface, processed and used for different purposes. So, mining. So, miners, they dig up some, when they dig up the surface of the earth, yeah, they could get some minerals. For example, they could get for example, what, I forget about it. So let's go about rock cycle. Oh no, it's not my report, it's my classmates' report. Oh, that's my report, thank you. And this rock cycle is to be followed by Marjorie. Yeah, okay. Marjorie Hanyang. Thank you.
So this is my report about rock cycle. So I will start my report. What is rock cycle? The rock cycle is a concept used to explain how the three basic rock types are related and how Earth processes over geologic time. Change a rock from one type into another. Plate tectonic activity along with withering and erosional process are responsible for the continued recycling of rock. So there are three basic types of rock cycle: igneous rock, sedimentary rock, and metamorphic rock. So let's start with igneous rock, a rock formed by the cooling and crystallization of magma or molten rock and at or below the earth's surface. So that picture is, his name are basalt. The basalt, that basalt is a is is a dark colored fine grained igneous rock composed mainly of plagioclase and pyroxene minerals. It most commonly form as an extrusive rocks such as a lava flow, but can also form in a small igneous bodies such as igneous dike or a thin seal. It has a composition similar to gabbro. So, sedimentary rock, a rock formed as a result of the withering process, either by compaction and cementation of rock minerals fragments or the precipitation of dissolved minerals. So, this picture is a shallow. Shallow is characterized by its tendency split into thin layers less than 1 centimeter into thickness. The property is called fissility. So the metamorphic rocks, these rocks form an existing rocks are subjected to intense heat and or pressure, usually over long periods of time. So this picture is a marble. That that is a type of this are this that one is a type of metamorphic rocks. So marble is a metamorphic rocks composed of recrystallized carbonate minerals, most commonly calcite or dolomite. Marble is typically not fully fluted, although there are exceptions. In geology, the term marble refers to metamorphosed limestone, but it's used in stone masonry more broadly in composes antimorphous limestone. So this is the example. This is the types of rocks. So the next one is, so I will explain the rock cycle. I will explain the diagram about rock cycle. So in this illustration, we can explain how igneous rocks turn into sedimentary or metamorphic rocks, and also the two types of rocks into different types of rocks. Let's start with igneous rock. We know that igneous rocks are rocks that harden from lava or magma. They are exposed to the surface of the earth, and that surface of the earth and we is on the earth's different agent of weathering and erosion. Because I sorry, when we say weathering, this is the breakdown rocks from being layer rocks to fragmentation, and any effects can be air, water, human, or animal or plant activities. Once we have a piece of rock, it is easier for it to be transformed from one place to another, and the process is called erosion, because it's fragmentation that we call hair sediment. Sometimes sometimes these sediments is superimposed upon overlaid with a new layer of rocks or soil deposits, and is subject to the process called compaction and cementation. So the so this piece of rocks doubles again, and the piece of rock formed from igneous rock is called sedimentary rock. How then does metamorphic rock and sedimentary rocks or the igneous rock by the presence of heat and pressure? Heat and pressure can change the composition of an igneous rocks, but it is not enough to melt igneous rocks, because the size of these minerals and composition changes. He is no longer considered as igneous rocks. He he can now be he can now be he can now be considered as the metamorphic rocks. How did sedimentary rocks become metamorphic rock? Like igneous rocks and sedimentary rocks can also be subjected to heat and pressure in a process of metamorphism, and can be transformed into metamorphic rock. Can metamorphic rock also become igneous rock? Yes, remember that metamorphic rock is a near heat sums. There are a great chance of metamorphic rock to melt and become magma. We know we 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 know we we know we know that magma is flowing onto the surface of the earth. Sometimes they come out through a volcanic eruption. So when magma is erupted or ejected from volcanic and it passes, we call it lava, and the lava that hardens will be considered as igneous rock. So so can can the magma also harden before it comes off of the world? Yes. So the difference is that the lava that hardens is called extrusive igneous rock, and the magma that subsides and the magma is also considered igneous rocks, but the classification is called extrusive rock is metamorphic, or can be it sedimentary rock? Yes. Know the Yes, we know that metamorphic rock are more visible in the deeper part of the world, and how they are subjected to weathering and erosion. One process has to do with mining and quarrying. So we cultivate the soil and the rock, and we see that when they cultivate rock, metamorphic rocks become fragmented or become sediments into a sediments. This becomes subject to compaction, cementation, and become sedimentary rocks. One thing that um, so, sedimentary rocks. So the igneous rocks, it will become a sedimentary rock. sedimentary rock, it will become a metamorphic rock. One thing that wants to share with us this lesson is that Earth is geologic reactive, and our world is full of mineral wealth with constantly circulating in our world. These minerals are important to our people, and it is important in the natural cycle of the world. We approve that of our rock cycle, and we approve the process of our world, because without that we also do not exist. And that's all for today. Thank you for watching and listening to my report.
Hi everyone, good morning. My name is Jimmy Manipin from Group 6. Today I am going to report the environmental effects of using non-renewable mineral resources. Non-renewable energy resources include coal, natural gas, oil, and nuclear energy. Once these resources are used up, they cannot be replaced, which is a major problem from humanity, as we're currently dependent on them to supply most of our energy needs. Removal and use of mineral deposits have harmful environmental effects. Every metal product has a life cycle that includes mining the mineral, processing it, manufacturing the product, and disposal or recycling of the product. Geology and non-renewable mineral resources. This process makes use large amounts of energy and water and results in pollution and waste. The environmental impacts of mining a metal ore are determined partly by the ore's percentage of metals content or grade. The more accessible higher grade ores are usually exploited first. Mining lower grades ores takes more money, energy, and water and other resources, and leads to more land disruptions, mining waste, and pollution. Several different mining techniques are used to remove mineral deposits. Shallow mineral deposits are removed by surface mining, in which vegetation, soil, and rock overlaying a mineral deposits are cleared away. The soil and rock called overburden are usually deposited in piles of waste material called spoils. Surface mining is used to extract about 90% of the non-fuel mineral resources and 60% of the coal used in the United States. Different types of surface mining can be used depending on two factors, the resource being sought and the local topography. In open pit mining, machines are used to dig very large holes and remove metal ores containing copper, gold or other metals, or sand, gravel or stone. Strip mining is any form of mining involving the extractions of mineral deposits that lie in large horizontal beds close to the earth's surface. In area strip mining used where the terrain is fairly flat, a gigantic earth mover strips away the overburden, and a power shovel, which can be installed as a 20-story building, removes the mineral deposit. Or an energy resource such as coal, the resulting trench is filled with overburden, and a new cut is made parallel to the previous one. This process is repeated over the entire site. Shovel extracts the coal and the overburden from each new terrace is dumped onto the one below. Unless the land is restored, what is left are a series of spoils banks and a highly erodible bank of soils and rock called a high wall. Deep deposits of mineral are removed by subsurface mining, in which underground mineral resources are removed through tunnels and shafts. This method is used to remove metal ores and coal that are too deep to be extracted by surface mining. Miners dig a deep vertical shafts, blast open subsurface tunnels and chambers to reach the deposit, and use machinery to remove the resource and transport it to the surface. Another surface mining method is mountain top removal, in which the top of a mountain is removed to expose seams of coal, which are the extracted figure 12.11. This method is commonly used in the Appalachian Mountains of the United States, with its removes after a mountain top is blown apart. Enormous machines plow waste rocks and dirt into valleys below to the mountain tops. Another problem is subsidence, the collapse of land over some underground mines. It can damage houses, crack sewer lines, break gas mains, and disrupt groundwater system. Surface and subsurface mining operations also produce large amounts of solid waste, three-fourths of all U.S. solid waste, and cause major water and air pollution. For example, acid mine drainage occurs when rainwaters that seeps through an underground mines or spoils pile from a surface mine carrier sulfuric acid, H2, H2S, excuse me, O4, produced when aerobic bacteria act on a mineral in the spoils to nearby streams and groundwater. According to the EPA, mining has polluted mountain streams in about 40% of the western watersheds in the United States, and it accounts for 50% of all country emissions of toxic chemicals into the atmosphere. In fact, the mining industry produces more of such toxic emission than any other US in. That's all. Thank you for watching.